change our genetics in order to not have any genetic conditions or diseases ever again. This is actually scientifically possible. However, it is currently illegal due to the disruption and ethical conditions that will come along with its legalization. But this is our future challenge that could change healthcare system as we know it. Well, the technology we use to do this is called CRISPR. However, before getting into these, let's do a small recap about DNA, as it's the base in order to understand how this technology actually works. Well, DNA is a chemical compound that contains instructions for all living organisms' growth and development. The DNA has a double helix structure composed of polynucleotides, and this structure is joined together by its hydrogen bonds. And we call that an organism's full set of DNA is called a genome, okay, so just so you know that. Now that we have gone over the structure of the DNA, let's actually understand how CRISPR actually works. Well, as I mentioned before, CRISPR is a technology that can be used to edit genes. The essence of CRISPR is actually pretty simple. It's a way of finding a specific bit of DNA from the initial structure, separating into the two strands, and from there getting that piece of DNA. And from there, the next step is to actually edit and alter that piece of DNA. This technology has the potential to transform medicine completely, enabling us to not only treat but prevent many diseases. Let me talk to you about an example of someone that has actually experimented with these, because we know the technology is currently illegal, but there are some researchers in this area that have experimented with it. He-Jian announced in 2018 the birth of two twin girls with edited genomes. He was actually able to do this by engineering mutations into the human embryos that then were used to produce babies genetically resistant to HIV. So what He-Jian ended up doing was leaping into an era in which science could rewrite gene pool of future generations by altering the human germline. The issue here is that, as I explained before, this is illegal, and actually He-Jian, after doing this experiment, he was imprisoned for 3 years and got a 3 million yuan fine, so not good. So this makes us ask ourselves, if he was able to be experimenting with this, does it mean that there's more people out in the world experimenting and we don't know about it?
And now I'm going to show you a map called the Legal Landscape. A survey in 2016 examined the laws and documents of gene editing and such activities that included that.
The survey labelled some of the countries restrictive and permissive, or somewhere in between. Brazil, Australia and Canada are all restrictive. Mexico is permissive. However, some specialists disagree that some rules might be interpreted differently.
So, here's the issue. It is seen as unethical due to how dangerous it could become. On one hand, we could reproduce great minds like Einstein, but on the other, we could create bad minds like Hitler. We could even possibly create evil villains like the ones out your favourite Marvel movie. Therefore, the future of CRISPR depends on the debate over the need for it and the potential consequences it could have. Many skeptics point out that although gene editing can help avoid passing some disorders, many of these conditions can already help to be avoided using a technique known as pre-implantation gene diagnosis, in which embryos created through in vitro fertilization are screened for specific mutations. But is this enough, or do we need CRISPR to transform our health care services and save lives?
So here are our future challenges. We know CRISPR does work and we can change genes with it, but it's illegal. So what if we created different policies that could differentiate what's ethical and what is not?
Today, the use of genetics in medicine allows diagnosis to be completed quicker, meaning it is giving us a better understanding of diseases. It allows personalised treatments to be made, improving the efficiency of diagnosis and treatment for patients. Sequencing of an entire genome allows non-coding variants to be detected, as well as disorders and mutations, which could also improve current treatments. However, currently, personalised medicine is thought to be driven by the want for wealth instead of health, which could be dangerous for individuals' health and well-being.
Food allergies are common and cases are on the rise to a point where it's a global health concern. However, food allergies can be very severe and sometimes it can cause death. Lack of treatment that is available is lacking in itself. If we could change genes so that we could create people to not have intolerances and not have allergens, we would save so many lives and improve the health of millions of people. We could possibly do this by taking the intolerances and the allergies out at the embryo stage so that there would be no allergens or intolerances altogether.
Another future potential is improving the outcome for diabetics. Insulin injections can control diabetes, but patients still experience serious complications such as kidney stones and skin infections. Scientists have developed a way to use the gene editing system CRISPR. The system edits mutations in human-induced pluripotent stem cells and converts them into beta cells. It has successfully been tested on mice, which has successfully reversed pre-existing diabetes in a lasting way. After transplanting corrected beta cells, there was a drop in glucose levels, suggesting glycemic control. If the gene editing system was legalised, there's a potential to reduce serious complications and solve the chronic condition diabetes. This has recently become a rapidly growing concern for the NHS, costing millions of pounds.
So we have to ask ourselves, do the potentials of CRISPR and cloning outweigh the negatives?
Is it worth the risk?